This is a structural audit of Mount Kailash, an object that forces a choice between impossible geology and what looks like impossible engineering. The official story is that Mount Kailash is a natural 6,638-meter peak in Tibet, its pyramid shape carved by simple glacial erosion over the last 2.5 million years. But that explanation crumbles the second you apply basic, real-world constraints. The core contradiction is this: natural processes are fundamentally chaotic and random, but the object we call Kailash is defined by a level of geometric precision that screams of intent. Let's start with the most obvious feature, the symmetry, and the official comparison used to normalize it, the Matterhorn. The claim is that both peaks were shaped by glaciers, so their similar pyramidal forms are to be expected. But this is where the official story first self-destructs. Look. A simple verification check is to pull the 3D satellite topography models for both mountains, something any practitioner can do with public domain data from NASA or Google Earth. When you overlay them, the claim of similarity becomes, frankly, an absurdity. Why is the official story's primary example of a similar natural formation so fundamentally different in its core geometry? The Matterhorn is a classic natural peak, jagged, asymmetrical, a chaotic form dictated entirely by the random weaknesses in the rock it's made of. It has a pyramidal suggestion, not a blueprint. Kailash, by contrast, displays a degree of geometric regularity that appears to defy natural formation. The four primary faces are vast, flat plains, and the ridgelines are sharp and unnervingly straight, meeting at a central apex. You cannot cheat constraints. These are two completely different classes of object. How can an official explanation rely on a comparison that is so easily and visually falsified? To test the flatness of Kailash's faces, you don't need to be there. You can run a plane-fitting algorithm on the high-resolution digital elevation model, or DEM. This is a standard survey check. The software calculates a best-fit mathematical plane for each face, and then measures how much the real-world surface deviates from that perfect plane. The results show a consistency that is a statistical outlier compared to any other mountain on Earth. Reality does not care about narratives. If random ice and wind carved this, where is the signature of that randomness in the surface topography data? Think about what erosion actually does. It's a lazy process. It follows the path of least resistance, always. It exploits cracks, faults, and softer rock layers, creating gouges, curves, and unpredictable organic forms. It does not produce four flat faces of a pyramid aligned almost perfectly to the cardinal directions. Any field geologist will tell you that nature works with approximations, not with the kind of tolerances you'd expect from a machine shop. What breaks first in any natural system is perfect symmetry. Why does this single mountain look less like the product of 2.5 million years of chaotic weather and more like it was designed with a T-square? The official narrative is asking us to believe that on this one mountain, the rock was of such uniform consistency and the erosive forces were so perfectly balanced for millions of years that the result was architectural. This is a fiction. The inputs required for this output are impossible to sustain in the real world. You'd need rock with no significant internal faults and a climate that delivered perfectly equal weathering on all four sides for a geological age. Stop buying it. That's not a geological process. It's a manufacturing specification. Why does the explanation demand a set of conditions that have never been observed to exist anywhere else on the planet? The claim of glacial carving requires a specific kind of glacier, a sheet or a series of mountain glaciers grinding away at a pre-existing massif. We can model this. We know how ice flows and how it cuts rock. The models show that for glaciers to produce 4 such symmetrical faces, the ice flows would have had to be perfectly uniform on all sides, moving at the same speed, with the same pressure, carrying the same abrasive load for millions of years. This is a logistical impossibility. A simple check is to look at the inputs. Snowfall isn't uniform, solar radiation isn't uniform, and the underlying topography that directs the ice is never symmetrical. How can an asymmetrical input produce a perfectly symmetrical output? You cannot cheat constraints. Glacial movement is governed by terrain, temperature gradients, and snowfall patterns, all of which are variable and asymmetrical. You can't get that level of sustained, symmetrical pressure in the real world. Do the simplest check. Look at any other glacially carved mountain on the planet. In the Alps, the Rockies, the Andes. None of them display this level of geometric precision. They show cirques, arêtes, and horns, all classic signs of chaotic, directional ice flow, not planar abrasion on 4 sides at once. So how can the one process cited as the cause fail to produce a single other comparable example anywhere on Earth? This isn't a minor discrepancy. It's a fundamental failure of the proposed mechanism. To accept the official story, you have to accept a series of impossibly fortunate events. You need a rock massif that was already, by chance, unusually symmetrical. Then you need glaciers on all 4 sides to behave in a way they behave nowhere else on the planet, for a period of time that is difficult to comprehend. Each step in the official explanation requires a statistical miracle. When you have to stack one miracle on top of another, a practitioner stops believing in miracles and starts looking for a different explanation. If the tool can't make the part, you're looking at the wrong tool. Why does the official explanation for Kailash's shape rely on a process that provably works nowhere else? Now let's move our focus from the overall shape to the surface details, the so-called steps or terraces that wrap around the mountain. The official story identifies these as natural strata of conglomerate rocks layered on a granite base, a typical feature of the Himalayan Flysch zone. This sounds plausible on paper until you actually look at them. High-resolution satellite imagery reveals horizontal and vertical features that look less like geological layers and more like, well, construction segments. Natural strata are not uniform. They pinch, they swell, they dip and curve based on the chaotic, ancient environment in which they were deposited over eons. A simple check is to trace these lines visually. They don't behave like natural layers. If these are just rock layers, why do they look like they were poured in sections? Be honest. These features do not form perfectly level, continuous terraces that wrap around a mountain with the regularity of a layer cake. A simple constraint check here is to measure the consistency. Using stereoscopic satellite photos or LiDAR data, you can calculate the height and depth of these steps. The question is simple. Are they random, as natural geology would dictate? Or do they exhibit a repeating, modular pattern? The visual evidence leans heavily toward the latter. We see massive, evenly spaced horizontal bands, almost like the tiers of a massive step pyramid. In between these bands, there are vertical grooves, giving the appearance of massive, stacked blocks. This is not how sedimentation works. Geology produces beautiful chaos, not repeating modules at this scale. What natural process lays down material in uniform, repeating blocks? Furthermore, consider the material science of the official claim. The story says this is conglomerate rock on a granite base. Conglomerate is essentially natural concrete, a mix of pebbles, sand, and other bits all cemented together. It's a heterogeneous material, meaning its properties change from one spot to the next. Granite is a hard, crystalline, igneous rock. These two materials erode at very different rates. A simple check is to look up their respective hardness and weathering characteristics. Granite is tough. Conglomerate can be relatively soft and crumbly. In any normal mountain, this differential erosion would create a mess. The softer conglomerate layers would wear away much faster, leaving the harder granite exposed in irregular patterns. The mountain would lose its sharp definition within a few millennia. How can a mountain made of two different materials, with wildly different erosion rates, maintain perfectly straight lines and sharp corners over millions of years of ice, wind, and rain? Yet Kailash retains its crisp architectural lines. This is a direct contradiction of the material properties we are told are present. The system is not behaving as the alleged materials would dictate. You cannot cheat physics. The softer material always gives way first, destroying any sharp geometric line between the two. The very existence of these sharp lines and planar faces suggests either the materials are not what they're claimed to be, or they are not subject to erosion in a normal way. The official story cannot have it both ways. It cannot be made of soft and hard rock and also be perfectly preserved. Which is the lie? The material composition or the process of erosion? The structural integrity of these steps is another major red flag. For natural strata to form such continuous, level ledges would need to be perfectly horizontal and of uniform strength for kilometers. Any geologist will tell you that the tectonic collision that formed the Himalayas, the very event that supposedly lifted Kailash, was one of the most violent geological processes on the planet. It folded, twisted, and shattered rock layers like they were clay. This is not a theory. It's the defining characteristic of the entire mountain range. The idea that these delicate-looking strata survived that immense pressure cooker and then emerged as perfectly level, wrap-around terraces is, to put it bluntly, impossible in practice. You can check the surrounding geology for yourself on any geological map. It's a crumpled, chaotic mess. What force kept these specific layers perfectly flat while the rest of the continent was being mangled like a piece of paper? We have to consider the failure modes. What breaks first? On a mountain made of layered rock, the joints between the layers are the primary weakness. Water gets in, freezes, and expands in a process called frost wedging. This pops the layers apart with incredible force. Avalanches and rockfalls should be constant, especially at this altitude. Yet, the structure of Kailash appears remarkably intact. The steps are too clean. A key check is to look at the base of the mountain for the debris. Where are the massive, chaotic talus fields, the slopes of fallen rock, that should correspond to the constant collapse of these alleged strata? A structure this large, this old, and made of layered rock should be sitting in a sea of its own rubble. The lack of this debris is deeply suspicious. So, if it's not failing like a layered mountain, is it because it's not a layered mountain at all? Let's shift lenses to the issue of access, which is where this stops being a geological puzzle and starts feeling like a security operation. The official reason for the complete prohibition on climbing Mount Kailash is its religious sanctity. It is sacred to, I think, 4 major religions. This is presented as a simple matter of respect. But colleagues, any specialist, will tell you that absolute information control is a powerful tool. The climbing ban isn't just a suggestion, it is strictly and forcefully enforced. This creates a perfect black box. No direct inspection is possible. No geologist can get on the rock to take a core sample. No surveyor can place a prism on a face to get a direct, ground-truthed measurement. All our data is remote, from satellites and aircraft. Why is ground truthing, the gold standard of verification in any field, completely off the table? Think about the cost and logistics of this enforcement. Enforcing a no-climb zone on a remote 6,600-meter peak in the Himalayas is a serious undertaking. This isn't a park ranger politely asking you to stay on the trail. This requires active surveillance and interception capabilities in a harsh, high-altitude environment. You have to factor in the cost of personnel, equipment, and sustained operations in one of the world's most inhospitable places. The resources required are non-trivial. The question a practitioner asks is, what is the return on that investment? What are they protecting that justifies that continuous cost? Is it really just about feelings? Compare this to other sacred mountains around the world. Many are climbed. Uluru in Australia was climbed for decades despite its deep sacred status to the Anangu people, and the ban was a recent negotiated change. Mount Fuji in Japan is deeply sacred and is climbed by hundreds of thousands of people every year. The absolute, non-negotiable nature of the Kailash ban is an outlier. It's a major anomaly in itself. Do the simplest check. Why this mountain? What makes its sanctity so uniquely fragile that it requires a level of access control that is almost military in its application? The official story of sanctity is an explanation for the motive behind the ban, but it doesn't address the effect. The effect is a complete block on independent verification. Think about it. If the mountain is exactly what the geologists say it is, a natural formation of conglomerate on granite, then what is there to hide? A close-up inspection would only confirm the official narrative. It would show the chaotic, non-uniform nature of the rock strata. It would reveal the telltale signs of random glacial scarring. It would, in short, put all the pyramid theories to bed, permanently. An open, internationally monitored geological expedition would be the ultimate victory for the conventional explanation. So why not allow it? This refusal creates a paradox. The only way to definitively prove the official story is to gather the one type of evidence that is explicitly forbidden. This is not a scientific posture. It's the posture of someone guarding something. When access to direct evidence is blocked this completely, a skeptical practitioner has to ask what that evidence might show. Who benefits from this information vacuum? Look, the story of sanctity is convenient, but it also functions as the perfect cover for something else. Is the ban really about protecting a faith, or is it about protecting a functioning site? The argument that pilgrims circumambulate the 52-kilometer path around the base, but do not climb, is often used to reinforce the sanctity claim. But this also serves the counter-narrative perfectly. Look at it from a security or an operational perspective. Allowing people to circle at a distance is a manageable risk. It maintains the appearance of access while keeping everyone far from the object itself. It's a perimeter. But allowing anyone to get close enough to touch, sample, or measure the structure is a different level of risk entirely. The prohibition isn't just about reaching the summit. It's about any and all vertical access. Reality does not care. This is a hard and fast rule with no known exceptions. If this is simply a pile of rock, why is the security protocol so absolute? Now let's examine the materials and the logistics of construction, assuming for a moment that this is an artificial structure. The counterclaim suggests it might be made of a single, uniform crystalline rock, which would require a quarry of unimaginable size. The official story counters this directly, stating it's a mix of heterogeneous rocks, conglomerate and granite, that were simply uplifted in place. No quarry, no construction. This is a direct, testable conflict. But the test is, again, conveniently blocked by the climbing ban. However, we can use logic and indirect evidence to pressure test the official claim. If Kailash is a jumble of different rocks, as claimed, it should have a messy composite signature on radar and other remote sensing platforms. Why do all remote observations show an object of incredible uniformity? Think about building something out of two different kinds of brick, one hard and one soft. Over time, the soft bricks will weather away and the structure will lose its shape. The building will begin to look lumpy and uneven. Kailash does not look lumpy. It looks like it was carved from a single, monolithic block of extremely high-quality material. Its faces are vast, planar surfaces. Its edges are sharp. These are not features that a composite material holds well over geological time. The visual evidence directly contradicts the alleged material composition. You cannot have it both ways. Either the appearance is an illusion, or the material science is wrong. Why doesn't its appearance match the properties of the materials it's supposedly made from? Let's apply a resource constraint check to both scenarios. The official story says the materials were just there, pushed up by tectonic plates 50 million years ago. This requires zero material transport, zero quarrying, zero energy input for construction. It's the ultimate free lunch. The artificial pyramid hypothesis, on the other hand, presents a logistical nightmare on a scale that is difficult for the human mind to comprehend. The sheer volume of material in a 6,600-meter pyramid is astronomical. To quarry it, shape it, and lift it into place would require technology and energy resources far beyond anything we possess today, or can even imagine. This is often used as the primary argument against the artificial theory. It's impossible. What breaks first in a project of this size?
Everything. Your tools, your workforce, your energy supply, your transport logistics. So if it's impossible, how is it there? But calling something impossible with known technology is not a refutation. It's an admission. It simply defines the scale of the problem. The fact that the structure exists in a form that defies the natural explanation forces us to confront this technological gap. The official story avoids this problem by claiming no technology was needed. But this only works if you ignore the evidence of the form itself. The form implies technology. The symmetry, the steps, the alignment, these are all hallmarks of design. You cannot have design without a designer and a set of tools. So which is more unbelievable? That nature randomly produced a single, perfect architectural monument, or that it was built by a technology we don't understand? The very geology of the area poses another deep problem for the uplifted-in-place narrative. The Himalayas are a tectonic collision zone. The rock is folded, shattered, and metamorphosed. It's a geological demolition site. To suggest that a single, coherent, mountain-sized block of rock was uplifted without being shattered into a million pieces is a huge claim that has no precedent. A simple check is to look at the surrounding peaks on any satellite map. They all show the scars of this violent process, the folding, the faulting. Where are the massive fault lines running through the structure of Kailash itself? Where is the evidence of the immense stress and deformation that the surrounding rock clearly displays? The mountain appears strangely isolated from the chaos around it. Stop buying it. It looks less like a piece of the local geology and more like something that was placed on top of it. How can a structure be born from chaos and yet show no signs of that chaos in its own form? Let's pivot to the lens of alignment and precision. The faces of Kailash are said to be aligned to the cardinal points: north, south, east, and west. The official story dismisses this as a coincidence, a result of regional geology and prevailing erosion patterns. But precision costs energy. Nature, governed by entropy, tends toward chaos, not order. Deliberate alignment is a signature of intelligence. It implies a purpose. A quick check with any good satellite mapping service confirms the alignment is remarkably close. It's not perfect, but it's far, far better than random chance would predict for a natural object of this scale. You can't just wave your hands and say, regional geology, without explaining the specific mechanism that produced this result. What specific fault line, what specific erosional force created four faces with this specific orientation? The official explanation is silent on the details. Think like a surveyor. To align a structure of this magnitude requires a fixed reference point, like the rotational axis of the planet. It requires advanced astronomical knowledge and the tools to translate that knowledge into lines on the ground. For natural forces to achieve this, the primary geological faults and stresses in the region would have to be perfectly aligned with the Earth's axis by chance. While regional tectonic grids exist, the level of precision seen at Kailash is, once again, a statistical outlier. It's too neat. This isn't a minor detail. It's a primary characteristic of the object. How can a random process produce a non-random, purpose-built looking orientation? This alignment isn't just a curiosity. It has functional implications. In ancient architecture, cardinal alignment was often tied to astronomical observation or religious belief. In a modern context, it might be tied to a physical property, for example, aligning with a planetary magnetic field. The debunked claim of a 6,666-kilometer distance to the poles is noise, a known fabrication designed to distract from the real issue. The real issue is the physical orientation of the object itself. It's a low-probability event. When you see a car parked perfectly parallel to the curb, you don't assume the wind blew it there. You assume there was a driver. Be honest. Why should we apply a different logic to a structure 1,000,000 times larger? The cost of this precision in a natural setting is the core of the problem. For a mountain to be shaped this way by chance is like throwing a bucket of sand and having it land as a perfect sandcastle. It's statistically possible, but practically absurd. The official story asks us to believe in this statistical miracle without blinking.
The alternative suggests the precision isn't a miracle at all. It's a design specification. The structure is aligned this way because it needs to be, for reasons we don't yet understand. This flips the script entirely. The alignment is no longer evidence of a lucky coincidence, but potential evidence of a function. Which framework better fits the observable facts without resorting to sheer, dumb luck? Look at the context. Kailash is not just a randomly placed peak. It is the source of 4 major rivers in Asia. It sits in a unique and critical geographical position. For its axis to also align with the planet's axis seems like one coincidence too many. A practitioner looks for
Patterns. When you see precision alignment, modular construction, and anomalous symmetry all in one place, you stop calling it a coincidence and you start calling it a system. You cannot cheat constraints. The constraints of random chance are unforgiving. So if it wasn't chance, what was it? Now we arrive at the most speculative but perhaps most important lens, the question of function. The counter-narrative claims Kailash is a crystalline resonator situated on a tectonic fault line. The official story, based on data from NASA's INSAR satellites, reports only standard tectonic activity and no detected anomalous energy or piezoelectric effects. This is presented as a firm debunking. But let's look at that a little closer, as a practitioner should. What is INSAR actually measuring? It's an interferometric synthetic aperture radar technique that measures ground deformation. It can detect uplift, subsidence, and sideways movement with incredible precision, down to millimeters. It is not, however, designed to detect high-frequency vibrations, piezoelectric emissions, or other more exotic energy types. So what does the INSAR data actually prove, other than that the mountain isn't moving up and down in a way the satellite can see? Saying INSAR found nothing is like using a ruler to measure temperature. You're using the wrong tool for the job. The absence of evidence is not evidence of absence, especially when you're not looking for the right thing with the right instrument. A proper check would require deploying a network of ground-based sensors, seismometers tuned to high frequencies, magnetometers, gravimeters, and broad-spectrum RF detectors. This is standard practice for geophysical surveys. The claim that no anomalous energy has been detected is meaningless without specifying what was looked for and with what tools. Why is the official debunking based on data from a tool that wasn't designed to find the very thing it claims isn't there? Second, let's reconsider the location. The mountain sits in a seismically active area, on or near major fault lines. This is a known fact. From a geological perspective, this is a dangerous place to be. From an engineering perspective, if you wanted to build a machine that draws energy from tectonic movement, this is exactly where you would build it. You would place it on a fault line to tap into the immense mechanical stress and strain of the Earth's crust. So the location, which is a liability in the natural mountain model, becomes a primary design feature in the artificial machine model. What breaks first? In the natural model, the mountain itself should be breaking apart. In the machine model, the location is the power source. Which model better explains its continued existence in a high-stress environment? The claim of a crystalline resonator implies a specific material property. Certain crystals, when subjected to mechanical stress, generate an electric voltage. This is the piezoelectric effect.
If the core of Kailash were a massive, engineered crystal, the constant grinding of the tectonic plates could theoretically power it.
This is a huge leap, but it provides a functional reason for all the other anomalies we've seen. A machine needs a power source. It needs a specific structure. It needs a precise orientation. The resonator hypothesis, while unproven, is the only one that connects the dots between the location, the shape, and the alleged material composition. The official story leaves them as a disconnected series of random accidents. Which approach is more scientific? Connecting the data points or ignoring them? We can't verify the crystalline core because of the climbing ban, but we can check for secondary effects. Are there any unusual magnetic field readings in the area? Are there any unexplained radio frequency emissions? Are there any documented, credible reports of seismic activity that is rhythmic or patterned rather than random? Most of this data is either not public or has not been collected with this specific hypothesis in mind. The no anomalous energy claim from official sources is based on a narrow set of observations with the wrong tools. It's a dismissal, not a thorough investigation. Do the simplest check. If you really wanted to disprove the energy anomaly claim, you would deploy a network of multi-spectrum sensors around the mountain for a prolonged period. Why has this never been done? The concept of Kailash as a machine is, of course, a work of fiction until proven otherwise. But the official story, that it is a natural mountain, is also a story. And it's a story that is looking weaker and weaker as we pick it apart. It requires us to accept a chain of low-probability coincidences that, taken together, beggar belief. The machine hypothesis may be wild, but it is internally consistent. It offers a reason for the strangeness. The geological story offers only chance. As a practitioner, you have to weigh the two. An unbelievable explanation that fits the facts is sometimes better than a simple explanation that ignores them. Why is the scientific community so quick to dismiss the functional hypothesis, instead of simply saying, we don't have the data to evaluate it? Let's apply the failure mode constraint again, but this time to the entire structure over its alleged lifespan. The official narrative states Kailash was formed by uplift 50 million years ago and achieved its current shape during the Quaternary Ice Age, around 2.5 million years ago. This means the structure, in its present, precise form, has survived for over 2 million years in one of the most geologically violent and erosive environments on Earth. This is a staggering claim that needs to be pressure tested. Think about what that environment entails. It's a high-altitude zone with extreme temperature swings, causing constant freeze-thaw cycles that shatter rock with the force of explosives. It's subject to some of the highest levels of UV radiation on the planet, which degrades rock surfaces. It's in a major earthquake zone. And it was subjected to massive glaciation that carved the entire Himalayan range. What breaks first on any structure are the sharp corners and fine details. Edges get rounded. Flat surfaces get pitted and gouged. The entire structure should have softened and slumped into a more typical, rounded mountain form by now. How has it resisted 2 million years of entropy? The official explanation for its stability is that the pyramid form is naturally stable. This is true in a general sense, but it's the stability of the details that's the problem. It's one thing for the bulk of the mountain to remain. It's another for it to retain the apparent precision of a freshly machined part after millions of years on nature's workshop floor. You cannot cheat the second law of thermodynamics. Order decays into disorder. A highly ordered structure like Kailash should be rapidly degrading into a disordered pile of rock,
and the evidence of that degradation should be all around it. Where is the entropy? Let's do a simple, brutal comparison. Look at the pyramids of Giza. They are just a few thousand years old, built in a mild, dry, desert climate. And yet, they are heavily eroded. Their outer casing stones
are mostly gone. Their edges are rounded. Their faces are pitted and worn. Now compare that to Kailash, allegedly 2.5 million years old, in a brutal alpine environment with extreme weather. Yet it appears to be in a much better state of preservation. This comparison is a profound contradiction. Stop buying it. How can a structure 1,000 times older, sitting in a 1,000,000 times harsher environment, be in better shape? This lack of expected degradation is one of the strongest, yet least discussed arguments against the official narrative. It implies one of two things. Either the age of the structure is completely wrong, or the material it's made of is something far more durable than the conglomerate and granite we're told to expect. Maybe the structure is much, much younger than 2.5 million years. Or maybe it's made of a material with weathering properties we can't explain. Or perhaps, to be speculative, it has some kind of self-repair mechanism. All of these are wild speculations, but they are forced upon us. The failure of the conventional model. The mountain simply shouldn't look this good for its age. It's an engineering absurdity. If it's as old as they say, where is the evidence of 2 million years of decay? This brings us to the alternative hypothesis. This is the one framework that attempts to unify all the anomalies we've discussed without resorting to an endless chain of miracles. The hypothesis is this: Mount Kailash is not a natural mountain. It is an engineered pyramid, a machine of unknown purpose and origin. How it might work is speculative, but follows from the evidence. It could be leveraging the immense energy of tectonic fault lines, perhaps using a massive piezoelectric crystalline core to act as a transducer, converting mechanical stress into another form of energy. Its structure, the pyramid shape, would not be decorative but functional, perhaps to focus energy or withstand unique stresses, and its precise cardinal alignment would be a functional requirement, possibly related to planetary magnetic fields or other geophysical properties. The uniform, highly durable material it appears to be made from would be a necessity for a machine intended to operate for millions of years. And why this hypothesis fits the constraints better than the official story is simple. It replaces a series of statistically impossible coincidences with a single unifying principle: design. The symmetry is not an accident. It's a blueprint. The regular steps are not strata. They are construction tiers. The precise alignment is not luck. It is calibration. The climbing prohibition is not just about sanctity. It is about securing an operational site. This hypothesis treats all the anomalous evidence not as noise to be dismissed, but as signals to be decoded. It provides a reason for the precision, a reason for the durability, and a reason for the secrecy. Is it provable? Not without access. But does it fit the available facts better? Yes. The official story, that this is all the result of random geology and erosion, remains profoundly insufficient. It fails to adequately explain the geometric precision that exceeds natural tolerances. It fails to explain the modular, step-like construction that defies the principles of stratigraphy. It fails to explain the structure's incredible state of preservation over millions of years in a harsh, dynamic environment. It dismisses the precise cardinal alignment as a coincidence and, most critically, uses the climbing ban to prevent any of its core claims from being independently verified. You cannot claim something is scientifically true and then forbid anyone from checking the work. To believe the official story, you have to accept that nature, just once, decided to act like a master architect. It took a random pile of rock in a tectonic collision zone and, using only the clumsy tools of ice and wind, sculpted a geometrically precise, cardinally aligned step pyramid. A structure so perfect, it looks like it was made yesterday, yet so old it predates our own species. A structure that, by sheer coincidence, sits at the nexus of major rivers and on top of a powerful geological fault line. You have to accept miracle after miracle, a chain of impossible luck. That's not science. That's faith. A practitioner, an engineer, a surveyor, anyone who works with real-world constraints cannot accept this. The number of coincidences has strained credulity past the breaking point. Nature builds things that are efficient, not things that are perfect. Kailash looks perfect. The geological explanation is a story woven to fit a pre-existing conclusion, a conclusion that is looking less and less tenable as our remote sensing data improves. The evidence does not point to a random act of nature. It points, uncomfortably, to an act of will. The verdict of this audit is clear. The official story is a failure. It does not fit the facts. If you want more forensic breakdowns of stories that don't add up, subscribe to the channel.